All right, good afternoon, everyone. And today we will be doing the Unit 6. You'll notice here it actually says Quest. It is the test review. However, Unit 6 was broken up into two parts. So the test was also broken up into two parts. So this is the review at the end of Unit 6, but we're only going to be reviewing half of Unit 6 here and not the entire unit. So in this particular part of Unit 6 that we will be reviewing is specifically functions and function operations. This would include addition, subtraction, multiplication, division, also composition, and then ending with inverses of functions. So to start us out at the top here, we have a lot of different function operations happening. In the first three examples, you see addition and subtraction. I first want to point out between example number 1 and example number 2, these are both addition problems. So the approach or the solving of these problems is going to be very similar. The only difference is in problem A, you have an X, which means that when you find your final answer, there will be an X in your answer. Versus in problem 2, they actually give us values, -2 and -3, that they would like us to plug in. So looking at problem number 1, if I were to solve this, it would actually kind of look more like a f of x plus g of x, which is actually how it's written in number 2, being slightly separated like that. In which case we would take our f function, that's a 4x minus 1, and then we would add our g function. Make sure that you are looking at g and not h. They give you 3 functions actually up at the top here, so you got to be careful to make sure that you're looking at the correct functions. So this one would be a 2x squared plus 3, and then it's a matter of combining like terms. Now in problem, and you should finish that, I'm not going to finish that problem for you, but in problem number 2, as I mentioned previously, the difference here is that we actually have numbers we are going to plug in. So rather than having f of x and g of x, like we have here in problem number 1, in problem number 2, we actually want to be finding f of -2 and h of 3. Notice that these are different numbers. Sometimes they could be the same number. So let's say that over here in problem number 1, maybe instead of an x, they give us 4. Well, then when we would break it up, we would actually put a 4 inside of here, but a 4 for both of those. So that would be an example where the number you're plugging in would be the same, but in problem number 2, you are plugging in different numbers. So first off, just pointing this out, make sure you're paying close attention to which function they actually want you to be plugging into. So in problem number 1, we used f and g, but in problem number 2, we're using f and h. So be careful with that. So f of 2 says that we need to go to the f function, and wherever I see an x, I'm actually going to plug in a 2. So I could go through and solve this. This should give me 8 minus 1 gives me 7. Then I'm going to add the h of 3, which again, make sure you're looking at the h function. That's a -2x, but instead of an x, we plug in a 3 for this one. So make sure that you are plugging in the appropriate value, in which case this should give us a -6, and then you could combine. Problem number 3 is very similar to problem number 1. So the only difference here is that it's subtraction rather than addition. And actually, these are the same functions as we had here in number 1. So we could actually take the f function, that's a 4x minus 1, take the g function, that's a 2x squared plus 3, and I just want to fix this so no one gets confused where the 4 came from. Excuse me. This was originally an x. But so in problem number 3, we could take the same f and g function. The only difference here is that it's going to be subtraction. Another big difference with subtraction, something to keep in mind, this as we have set up right now is actually not going to give you the correct answer. Because when you look at it in this format, it's kind of saying that we're subtracting the 2x squared, but we're not subtracting the entire g function. And if you look up top here, we should actually be subtracting the entire g function, which is why parentheses is going to be so important in a problem like this. If we put parentheses in this, we now see that negative sign having to get distributed, giving us a 4x minus 1 minus a 2x squared, and then last but not least, a minus 3. In which case, again, combining like terms as you see fit, and I'll let you finish that problem. Moving downward to the next one, we have multiplication. Doing just some comparisons again, number 4 and number 9 are both multiplication problems. Be careful with number 9 because they're very similar to what we just talked about. They actually give you values. So make sure you find the value of h of 5, find the value of f of 5, and then multiply those two together. Now in number 4, they do not give us a value of x, in which case, just like the addition problem and the subtraction problem that we just did, we're going to take the f function, that's 4x minus 1. Again, notice how I use parentheses. And we are going to multiply it by the g function, 2x squared plus 3. In a problem like this, you're going to end up foiling first, outside, inside, last in order to get your answer. Now, I'd like to take a moment to point something out in problems like this, and you see it in a lot of the problems, so I just want to address it here. If you give a quick kind of overview of all of these problems, I want you to take notice of something. Check out how a lot of these problems are followed by in parentheses x, okay? And I could go through, and a lot of these have in parentheses an x following the problem. So a lot of times, especially with a problem like number 4, a lot of times people are like, oh, you know, I can clearly see that I have f. Whoops, that was a very large font. Let's try that again. I have f and I have g, and clearly I'm multiplying them. So they do this multiplication, but then they feel this need to tack on an x afterwards. I want you to be cautious of this because I see that a lot. Please note that the parentheses that have the x is referring to the left side of our functions that are given to us. But when we start solving the problems, whether we're doing, you know, addition or subtraction or whatever we are doing, we are looking at the right side of the problem. So you don't have to worry so much about the parenthesis of x afterwards, because that's just referring to the left-hand side, which is always given to you when they're asking you the question. But when we go to solve it, we use the right-hand side. And that's why a lot of times in class, I actually encourage you guys to actually rewrite the problems so that it would look more like this, f of x times g of x. That way you can see where is this x going. It's going right behind the f and right behind the g, but it does not affect the other side of our equation, okay? Because what this would kind of look like, I would have the f of x times g of x over here, there's the x's, and then on the right-hand side having our actual equations. So again, all the math and operations that we're doing is referring to the right-hand side of our equation, in which case we don't care about the parenthesis of x. It does not affect our problem, okay? So at this point, we've looked at addition, subtraction, multiplication. Division is a nice, easy one. So I'm going to jump down here to number 8 real quick. So with division, this one's actually kind of fairly straightforward. It says that we have the f function over the g function, and I have to zoom back out because I don't remember the f function. So let's see, our g function was a 2x squared plus 3, and our f function was a 4x minus 1. So at this point, that kind of is your answer. That's the g function divided by the x function. Very rarely can it be simplified. I'm not ruling it out. It can, you know, sometimes problems like this can be simplified. But looking at this right now, this is a problem that cannot be simplified. So that is your answer. However, there's always a catch. We do have to account for that the denominator, this 4x minus 1, the denominator can never equal 0. So when I'm saying that I have this variable x and I don't know what x is, in theory, x could be anything. X could be a 2, x could be a negative 100, x could be anything. But we do have to be cautious that no matter what, that x does not result in my denominator being a 0. So what we're kind of saying is that 4x minus 1 is not allowed to be 0. So that's great. We acknowledge the fact that 4x minus 1 cannot be 0, but more specifically, what can x not be? In which case, we do have to do a little bit of solving here, and we get ourselves 4x cannot equal 1, which means that x cannot equal a 1/4. This is what we call a restriction, in saying that x can be anything its little heart desires, but it cannot be a 1/4. So make sure that anytime that you're doing a fraction that you check for those restrictions, and restrictions will always be there if you have a variable in the denominator, which is the case in most of the problems because we are dealing with functions, meaning they do have a variable in them. Okay, so at this point, we've actually gone through 4 of the 5 operations. And for our last operation, we are going to be looking at this open circle. Now, I do want to point out that the open circle does not mean multiplication. So a lot of times when people look at this problem, they're like, oh, f times g. But if it was multiplication, then it would have been more like problem 4. And problem 4 and 5 are very clearly different problems. But the only difference is one has a closed circle, one has an open circle. How does that make a difference to us? Well, whenever you see an open circle, rather than it being a standard, f plus g or f times g, whatever the case be, anytime you have an open circle, it actually falls under a different rule, in which case now we actually have a function within a function. And to understand that is a very kind of complicated concept. I kind of refer to it as, if you've ever seen the movie Inception, a dream within a dream. That's kind of what compositions or those open circles do, is it's taking one function and actually plugging it into another function, which again, that's kind of a deep concept. So let me kind of help you guys visualize this specific problem. So bear with me here, give me just a second as I transition to a document camera so that we can see my hand. So bear with me, give me a second. There we go. Okay, so what I have for you guys is a little visual to help you better understand composition. So if you've been struggling with composition, let me see if I can help you better understand it. So for this, I picked just a random f of x. Okay, so I picked this out of nowhere. This is not in your review packet. This was just a problem I thought of all on my own. And let me help focus the camera. Okay, so here's my f of x. Going back to what we had just talked about in some of the previous problems, let's say here for a second, I wanted to find what f of 4 was. So what that kind of means is on this side, rather than an x, I now have a 4. So what that means is on the other hand, I want to come over here and wherever I see x, okay, so again, this x right here, and actually I can cut it out on this side too. Okay, so I still have my function all put together, but they're asking me f of 4. And what that means is that rather than this x, I have a 4. Okay, and you can kind of see that x becomes a 4, f of 4. What that means to us is on the other side, this x is also going to get removed and replaced with a 4. Now, when we do that replacing, I do want to point out that it should be in parentheses. And so what our problem now looks like would be a 2 parentheses 4 plus 1. So our answer for a problem like this would become 8 plus 1 and gives us 9. So what does f of 4 equal? F of 4 equals 9. Okay. Now this brings us to how this relates to the problem we were just doing. So the problem we were just doing, as just a small little recap here, our problem on the previous page was a f open circle g of x, in which case I told you guys that the open circle means composition. So we would rewrite this with the g of x on the inside. So we have the problem f, parenthesis, g on the inside. So let's come back to our example here. We have f of x equals 2. I'm going to bring the x back here for a second. So here's our x plus 1. So there's our f function. And what they're asking us to do is to take another function, let's call it the g function here. And let me dice this up a little bit. And what they're asking us, look right here, they're asking us to have f parenthesis g of x parenthesis. So what we're kind of doing here in this problem is we're going to take this x, let's remove that x, I'm going to need to scoot this over a little bit, remove the x, and we are filling in the g of x. Okay, so now what you're seeing is exactly what the notation we have up here. F parenthesis g of x parenthesis, exactly what they're asking us to find. So they want to know, what does this equal? Well, the process that we just did, just as a recap, we took this x out, the x on the left-hand side, we took that x out and we replaced it with a g of x, which means, and I just want to remind you guys and show you that g of x was equal to x minus 4, which means that I want to, on the right-hand side, I want to do the same thing. So the right-hand side of our g function, I want to do the same exact thing that I just did over here. So on the left-hand side, we pulled x out and we replaced it with the g of x. On the right-hand side, I want to do the same thing. So I'm going to pull this x out, we can throw it away, and I want to plug my g of x in where I see that. Okay, so it's the same idea on both sides, that on this side, what was originally an x, we pulled the x out and we replaced it with g of x, the left side. On the right side, I did the same thing. I pulled the x out and I replaced it with whatever the g of x was. And again, it's just like if I was plugging in a whole number, but instead of plugging in like a 4, I plugged in another function. So as far as solving this, what would it look like solved? Very similar to what we talked about with the 4, we're going to have 2 parenthesis x minus 4 close parenthesis plus 1. So the original equation, just to give you this visual, the original f equation was a 2x plus 1. And all I did was I pulled that x out and I replaced it with my g function and the entire g function. Okay, and you could keep doing this. We could do it the other way around. I could do f with g inside. That's totally different. That would look like this. We would have the f function. Sorry, I would do it the other way around. We would have g on the outside, f on the inside. So it does kind of change the problem, the order in which you go. But for this particular one, we had the f function on the outside and we plugged g into it. So then on the right-hand side, we had the f function and we plugged g into it. So this answer then, if I were to solve this, would give me something like 2x minus 8 plus 1, 2x minus 7, final answer. So that's function composition for you. And again, that's anytime you see that open circle, you should be thinking about which function is getting plugged into which function. Now switching over back to our review packet here. Boop. Okay, so we have the exact same problem, the f with the g of x, but of course, this is dealing with the functions that we got in the review packet. So to refresh my memory, I'm just gonna, so I don't have to zoom all the way out. In this problem, the f function, I should do this in green, the f function was a 4x minus 1. And what we're doing is we're taking this g function and we're plugging it in as the x in that problem. So I'm going to remove the x just like we did when I was doing the visual. And I'm going to need a little bit more space here. So I'm going to scoot the 1 over. I got rid of the x, and what am I going to plug in there? I'm going to plug in the g function, which was a 2x squared plus 3. And so that would be the function I am now solving, in which case you'll see a little bit of distributing happening here. That would give me 8x squared plus 12 minus 1. and then I'll let you solve that. Okay. Number 6, as you can see, this one's not written with the open circle, but you can see the g of x is inside. So this is a function composition problem, very similar to number 5. And actually, if I were to rewrite number 5 for you guys, whoops, I already did. My bad. I actually already rewrote it for you. When you look at this, what do you notice between 5 and 6? Well, actually, 5 and 6 are the exact same problem, guys. So that makes it very interesting for us. And we're like, oh, they're the exact same problem, f with g inside. Where does the difference lie? The difference lies in the x. So at this point, you have two options. Since it's the exact same problem, in theory, I can take the answer from this one and bring it over here. 8x squared plus 11. That was my answer. But instead of an x, as I pointed out, for this problem, we have a 1, which means wherever I see x, I need to replace it with a 1. So that will give me 1 squared, and I'll have 8 times 1 plus 11 gives me 19 as my final answer. So that's option number 1, is basically going through the process that we did over here with composition, but then at the end, plugging in a 1. Option number 2, which some of you may be familiar with, is saying if I have f g of 1, whoops, that's supposed to be a 1, boop, then let's actually figure out what the heck is g of 1. So if I go to my g function and I say, let's figure out what g of 1 equals, that's going to be a 2x squared plus 3. We're going to plug in a 1 right here and solve. Well, 1 squared is still 1, times by 2 is 2, plus 3 gives me 5. So g of 1 equals 5. This is option number 2 for the record. It's going to give us the same answer. So if I know that g of 1 is 5, let's come up here and replace that with a 5. And now the only question I'm being asked, putting aside what they originally asked us for, the only question I'm at this point is finding f of 5. So let's go to the f function. That's a 4x minus 1. We plug in a 5 and we solve. Well, 4 times 5 is 20, minus 1 is 19. So you see here, it does end up giving you the same answer. So you can either plug the 1 in at the very end, do all of the work, simplify it down, and then plug 1 in at the end. Or you can plug 1 in at the beginning. But if you plug 1 in at the beginning, make sure that you take that new number that you get, and that's what you're going to be plugging in for the f, not 1. So sometimes people try to plug in 1 for both of those. It should not get plugged in for both. It gets plugged into the g, and then you try a different number for the f. Okay, so all the other problems do fall under that line. Even problem number 12, even though this has 3 layers, the truth remains that you could find h of 2. That's going to give you a new number. Take that new number and plug it into f. And then take that new number you get from f and plug it into h. On the last page, we go into inverses, in which case I'll try to keep this short and sweet here. But with inverses, long and short, keep it nice and simple. As a reminder, f of x, g of x, all those different things, that's just a fancy way of writing y. For an inverse, you actually end up switching the x and the y and solving for y. So what my equation will look like is x equals parenthesis 7y plus 2 squared. So you literally just switch the x and the y location. Don't change any of the numbers or anything like that, just switching the x and the y. Once you've switched the x and the y, you've kind of done the hard part. And now it's just a matter of trying to get y by itself. So in a problem like 13, I'd actually want to get rid of the square because it's kind of grouping everything together right now. So to get rid of a square, I square root both sides. That gives me the square root of x equals, and then on this side, we're going to have a 7y plus 2. Again, still trying to get the y by itself, so doing a little subtraction gives me the square root of x minus 2 equals 7y. And then last but not least, dividing both sides by 7, that would give me a square root of x minus 2 over 7 equals y. Now, some small details that you might have noticed going through this. I did add in this plus or minus. That happens anytime you square root a variable. So we had to square root y, which means we're getting a plus or minus. Another thing that you might be wondering is in our notes, you see things that are written like this, where you have the f of x, but this little -1 appears. When you see that -1, all it's really saying is that it's not just some random y equals problem. This is specifically the inverse of f of x. So the little -1 just simply means that this is an inverse. It's a notation. It doesn't change the way that you solve. It doesn't change your answer. You don't have to do anything with it. It is simply a notation labeling it as an inverse. It's just like, why'd they pick h of x rather than f of x? It's just a label. It's just a notation. And that's the same thing with the -1. It's just a label saying that it is, in fact, an inverse. So in all of these problems, that's what you want to be doing, is switching the x and y and then solving for y. To determine if something is an inverse, we actually learned 2 methods to doing this. And I'm not going to go through them in full detail. If you need more detail, go to your notes. But option number 1 is to do composition. So you could compose the h with the f or f with h. Either's fine, one or the other or both. If your answer is just an x, then it's an inverse. If your answer is anything other than an x, let's say x plus 3 or x, divided by 2 or x squared or 4x minus 1 over 9, if your answer is anything other than x, then it is not an inverse. Okay? So again, keeping an eye out for that variable all by itself. Sometimes that might be an n, by the way, or other letters, but the idea is that the variable is by itself, then it's an inverse. If it's not by itself, then it's not an inverse. The other option that you may choose to go for, so you either are doing composition, or the other option would be going through the process and saying, can we find the inverse of h? So let's say that you find the inverse of h. So it looks something like this. We would switch the x and the y. That gives me y plus 2 over 3 plus 1. Do a little bit of quick solving. Again, I'm not going to walk you through the steps here. I'm just going to blow through these a little bit. Multiply both sides by 3. That gives me 3x minus 3 equals y plus 2. That gets me my final answer of 3x minus 5. So my h of x, the inverse, should be a 3x minus 5. So again, the inverse of h is 3x minus 5. Does that, yes or no, match the f function? And the answer is no. Therefore, these are not inverses. Okay, so that's option number 2, is just straight up finding the inverse to one of the problems. If it matches the other function, they're inverses. If it does not match, then they are not inverses. Okay, so that's the idea. You can practice that in number 20 as well. There's just one last thing that I want to remind you guys of, and that's graphing. So there are some graphing problems on the test, in which case I just want to give you a brief review here of this. You might need to go back to your notes for a deeper review. But if they ask you to graph the f function along with its inverse, start out by just graphing the f function. For the record, this is a y equals mx plus b. So we would start at our a y-intercept, that's 5. My slope is an up 3 over 1 or down 3 over 1, so I could kind of get my slope going. Again, this is not an exact replica, but just giving you an idea or picture. if that is my regular function, then the inverse function, which I'm going to do in green, would say, let's take every single point here. So this point, I know that one for an exact, this was 0, 5. And inverse says that we switch the x and the y. So if I switch the x and the y, that's going to give me a point at 5, 0. And then I would pick another value. So this value over here, this is going to be 1, 8. So the inverse is going to be at 8, 1. Okay, and I could find maybe just one more for you guys. Again, thinking in my head, that's going to be -1, 2. In which case, if I flip that, that's 2, -1. 2, -1. And again, each of these points, all I did was switch the x and the y, switch the x and the y, switch the x and the y. That gave me a new graph that looks something like this. That is your inverse graph. Okay, so when it comes to graphing, it's nice because you don't really have to do any fancy, like over here, how we had to move this around, or up top here, moving the x and the y and solving. When it comes to graphing, you just graph one, find a few points like this on that graph, and literally go through each of these, switching the x and the y. And when you switch the x and the y, those will give you new points, creating your new inverse graph. And that takes you through our function review.